Hello, ladies and gentlemen. I hope everyone is doing well today. Today we're taking a look at mole calculations found in our Unit 4 Notepad. So this is the first unit where dimensional analysis will come back. Remember, dimensional analysis was from the previous unit. We're going to start with a little bit of a review. So remember, your 4 steps for dimensional analysis are found right here. I'm not going to take the time to talk about them because it was just the last unit. However, I will take the time and solve the first question. So this is one of the questions that was written by one of you guys from your poster project. So it tells you you own a candy shop and you decide to take 50 cases of peanut butter cups. How many peanut butter cups do you have? So we can look at our dimensional analysis steps. The first step is to set up our T and write what we're trying to convert in the top left corner. So what we're trying to convert, we find in our problem, 50 cases of peanut butter cups. So we will write 50 cases. And what we're trying to convert to is how many peanut butter cups do you have? So we can see where cases are in our units, conversions. So we see cases are here and peanut butter cups are here. Before you can convert to peanut butter cups, you need to convert to packages first, because then packages are linked together. So we would put cases on the bottom to make sure they cancel, and packages on the top. We would then put packages on the bottom. Whoops, oh, did not realize it was so blurry. So we put packages on the bottom, and peanut butter, PB, peanut butter cups, on the top. Remember guys, step 2 is writing our units in so they cancel. Note, before I go to step 3, there are no units written in, or sorry, no numbers, only units written in my T. So we can look, we would see we have cases and packages. So we need to use a conversion that has cases and packages. We put a 1 next to case, 16 next to packages. The next one, packages and peanut butter cups. So we look for that conversion. We put a 1 next to package and a 2 next to peanut butter cup. Remember guys, when you solve these, you multiply the numerators together, multiply the denominators together, and then divide. We don't need to divide by the denominators because they're 1. So we would multiply 50 times 16 times 2, and when you do that, you find you have 1,600 peanut butter cups. Don't forget your units. We can add that to step 4, units. Don't forget your units when you are finishing these problems up. So you can do step 3 the same way. Throughout this packet, whenever you have to do dimensional analysis, make sure you go through the steps. I would like to see which step you get stuck on. I know once a lot of people start doing the steps, it makes a lot more sense. So go through the steps, do what I wrote down. It will be helpful. Next we're thinking about quantities. So this is where we're going to learn what a mole is. So a mole is just the quantity of atoms, just like a dozen equals a quantity of eggs. So I know in this part I don't tell you what a mole equals yet, but it's worth writing down that 1 dozen always equals 12. Just like a dozen moles, 1 mole always equals 6.02 times 10 to the 23rd. We'll talk about this a little bit more later, but just know this relationship. Just like 1 dozen is 12, 1 mole is always 6.02 times 10 to the 23rd. Before we start using that number though, we're going to take a look at the relationship between moles. So, to help us, we have 2 boxes. In this first box, it tells us right down here that we have 1 mole. This 1 mole of neon is equal to 20 grams. And then I counted the dots and told you that it was 6 dots. We can do the same thing on the right side. So on the right side, it tells us we have 0.5 moles, we have 10 grams, and then I counted up the dots, which is 3 dots. That makes sense because we have half as many dots, so we have half as many moles, and we have half as many grams. So we can use these relationships to help us answer questions 3 through 6. So I'll help us with 3 and 4, and then you can do 5 and 6 similarly to how I do 3 and 4. So in the following container, we want to put black dots to represent 2 moles. So we know that 1 mole is 6 dots. So if we have twice as much, then we're going to have 12 dots, because 6 times 2 is 12. So we add 12 dots in. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah. So then next we need to think about the mass. So remember, we doubled the amount of dots we have, we doubled the amount of moles we have, so we're also going to double our mass. So to find for our mass, we would do 20 grams times 2, which would give us 40 grams. So similar to how I did 3 and 4, work on 5 and 6. Number 5 tells you have 30 grams. So what do you think you have to multiply everything by? Next. So next we're going to think a little bit about more what a mole is. So I already talked about this on the front, but it's so important, we're going to talk about it again. The quantity 6.02 times 10 to the 23rd is Avogadro's constant, and we call it a mole. Just like 12 is a dozen, the quantity 6.02 times 10 to the 23rd is called a mole. And that's what we see written down here. So down here you see 1 dozen equals 12. 1 mole is always going to equal 6.02 times 10 to the 23rd atoms or molecules. So by definition, the mole is a quantity of atoms necessary to equal the element's atomic mass. Remember guys, we just learned atomic masses. They're the mass that's found on the periodic table. And remember, it's the average of all the isotopes. So right down here, we can put in simpler terms what that just says. 1 mole of any element is always equal to the mass that's found on the periodic table. So right below it, it provides you with an example. It talks about sodium, Na. Sodium has an atomic number 11, so you're welcome to look it up on your periodic table to match the mass. But sodium has a mass of 22.99 grams. This mass is equal to 1 mole, and then that 1 mole is going to equal 6.02 times 10 to the 23rd atoms of sodium. Oh, sorry, that was a little confusing because the bottom of the next page was showing. But there's nothing else to write. So 1 mole of sodium is 22.99 grams, and that's also equal to 6.02 times 10 to the 23rd atoms. The next page provides us with one more example. This time it wants us to use gold. Gold is element 79. The mass of gold is 196.97 grams. Because this mass was found on the periodic table, we know it's the mass of 1 mole. Because of the mass of 1 mole, we know we have 6.02 times 10 to the 23rd atoms of gold. So this is kind of the relationship that we are going to be using. So questions 7 and 8. So change the word atom to mole. I don't know why I wrote that instead. I'm sorry I made a typo. There's a few typos in this one that I'll talk about. And then also to help you guys, aluminum's atomic number is 13. So remember, it's asking for the mass of 1 mole. Whenever you find the mass of 1 mole, it's the mass in the periodic table. Question 8 is asking you pretty much the same question. It's just asking it in a different way. So this time it's asking you the mass 6.02 times 10 to the 23rd atoms of aluminum. What's the mass of aluminum? So what you have to remember here is that saying 6.02 times 10 to the 23rd atoms or molecules is another way of saying 1 mole. Since 1 mole equals 6.02 times 10 to the 23rd atoms or molecules. So basically I'm asking you number 7 again. I'm just testing you to make sure you know that 1 mole is always 6.02 times 10 to the 23rd atoms. So down here for 9 and 10, to answer 9 and 10, this time it's talking about pennies and sand. To answer this question, remember guys, 1 mole is 6.02 times 10 to the 23rd. Use that relationship to help you with 9 and 10. So now we come to a little bit more information. So now we're going to compare atomic mass to molecular mass. So remember guys, atomic mass is the mass of an atom. The mass of an atom, remember guys, atoms are single elements, elements that are alone. The molecular mass is the mass of a molecule. Another word for molecule is compound. So it's whenever you would have your elements bound together chemically combined, that's when we're trying to find the mass of a molecule. To solve for the mass of the molecule, all you do is just add up the masses of the atoms. Remember, the atoms are the single elements found on the periodic table. When you are doing these, you are allowed to round the masses on your periodic table to the nearest whole number to make the math a little bit easier. So down here, the first example in this paragraph is calculating the mass of the molecule water, H2O. We know that the mass of hydrogen is 1, the mass of oxygen is 16. So then we add together. It's explained in here, but I want to just show you what it looks like. So we have the mass of water. So you would take the mass of hydrogen, 1.0, and you would multiply it by 2. You multiply it by 2 because you have 2 hydrogens. You then do the same thing for oxygen and add it together. So we look up the mass of oxygen, it's 16. So we write 16.0, and then we multiply by 1 Because when nothing's written, we assume it's a 1. Sorry, that was a little blurry. This is focus in. Yeah, so we can add little 1s whenever anything isn't written. So we do 16.0 times 1. And then you would solve this and add, and you get 18.0 grams per mole. There is a second example right below. This one is aluminum chloride. So we do the same thing. The formula is AlCl3. Remember, guys, when nothing's written, it's a 1. So if it helps you, you can write a little 1 in there. So next we take the mass of 1 aluminum, which is 27.0. So you do 27.0 times 1, because there's 1 of it. And then we would add it to the mass of 3 chlorines. Chlorine has a mass of 35.5. I know I said you can round, I just didn't do it in this problem, but don't be confused. Round to the nearest whole number. You could write that as 36 times 3. Then once you add together, it comes out to 133.5 grams per mole. So one thing worth noting, guys, so we know that 1 mole equals the mass of an atom in grams on the periodic table. Well, it's the same thing for molecules. You found the mass on the periodic table, so it's still 1 mole even though you added it together. And you can even use the units to help you. Look at the units. The units are grams per mole. Remember when we were talking about miles per hour? It was miles per every 1 hour. Grams per mole is the same way. It's the amount of grams per every 1 mole. It doesn't change even though these are molecules. Remember, guys, and it's because molecules are like compounds, they chemically combine to form one substance. The next thing that's important is molar mass. So the molar mass is always the mass of 1 mole of a substance, whether it is an atom or a molecule. If the word molar mass is in there, don't be confused. It's the mass of 1 mole of anything that's found on the periodic table. So all you have to do is look at the periodic table for your masses if you see the word 1 mole or molar mass. So we can do a couple problems. So you can round your masses. Don't forget, round your masses on the periodic table to the nearest whole number. It will make your math easier. I don't think I need to show people how to calculate the molecular mass. I already showed 2 examples over here, so use that work to help you. When you are thinking about 12, so remember, guys, so it's asking you how many molecules it would need. So what you need to remember is that 6.02 times 10 to the 23rd molecules or atoms is equal to 1 mole, which is equal to the mass on the periodic table. Is this the mass? Is this the mass from the periodic table? Remember, it should match up with your question number 11 because it's the same molecule, so you don't have to do it twice. But remember, if this is the mass from the periodic table, then it's really easy. It's just 1 mole. So try to figure that out. Let me know if you get stuck. Question 13. So question 13 is finding the molar mass. Remember, guys, molar mass means that the mass is on the periodic table. So remember, this is 1 mole, the mass of 1 mole. And we find that on periodic table. Don't forget to include your units. And then the other part that I want you guys to think about and answer as well is how many moles are in each of these as well. Remember, if you find your mass on the periodic table, it's pretty easy to figure out how many moles you have. Information. So information, so now we're beginning mole conversions. So when we do mole conversions, we need to use dimensional analysis. This is the first time it comes back throughout the year. It will come back again, so make sure we practice and do these the right way. So your dimensional analysis steps, remember, if you forget, you can find your steps on the front. I have an example right here. Oh, before. So one thing that's worth noting, you're going to see me do it a lot when I write these, is mole is abbreviated MOL, so you don't need to put the E at the end. And then, just like the 2-step problems we did before, instead of converting to the base unit first, we need to convert to mole first. Mole is the universal unit. Once you're in moles, you can convert to anything else. The few conversions that will be really helpful when we're doing these problems, so you would need to know that 1 mole equals 6.02 times 10 to the 23rd atoms or molecules. Remember, guys, atoms, so this term is used when the element is alone. Molecules, remember this term is used when it's a compound or molecule, something bound together. And then the last thing we've been using most of this packet is 1 mole is the mass found on the periodic table. So the example we need to convert is how many grams or how many atoms of carbon does it take to equal 23.5 grams. So we can solve this problem right here. So step 1 of our dimensional analysis is to set up a T and write what we're converting in the top. 23.5 grams of carbon. One thing that I want to point out is you need to tell me which element you have. Get in a good habit now, because later in the year, I've told you guys dimensional analysis comes back, you're going to be calculating grams of like one element to grams of another element. So you will have to specify your elements or else it gets very, very confusing. So remember guys, before we can convert from grams to atoms, you need to convert to moles first. So to convert to moles first, moles would be on the top, and then our grams of carbon would be on the bottom. To make our moles cancel, now our grams would cancel. We're not quite in atoms yet. So to make our moles cancel, we would put moles of carbon on the bottom. Oh, remember we need to put moles of carbon on the top. And then we would put atoms of carbon on the top because that's what we're converting to. Our moles would cancel and we'd be left with atoms. Now we go through and plug our numbers in. So the first one has grams and moles. So we can use the 1 mole equals the mass found on the periodic table. Remember guys, the mass is grams. So that's how we can tell you have grams and moles. So we use moles and grams in our conversion. So we put the 1 next to mole because we see a 1 right there. And then we look up the mass on the periodic table. Carbon's mass is right here. Remember, you can round to the nearest whole number. So all we do is put in a 12. And then the other conversion you need is right here. 1 mole equals 6.02 times 10 to the 23rd atoms or molecules. So we put 6.02 times 10 to the 23rd atoms on the top, 1 mole on the bottom. Then you solve this. Remember, you multiply the numerators together, multiply the denominators together, and then divide. You should get the answer 1.18 times 10 to the 24th atoms of carbon. Don't forget your units, guys. Units are important. I need to know what you converted to. So solve questions 14 and 15. Solve them the same way that I just solved this example. Use the 4 steps that are on the front, the first page. Remember, when you are solving these problems, make sure you attempt each step. I want to know which step you get stuck on. Yeah, I hope everyone has a wonderful day. Oh, like always, I'll end with a joke. So guys, here goes. Can a kangaroo jump higher than a house? Of course! Houses don't jump! Well, I hope everyone has a wonderful day. I will see you guys in class. Bye.